Tyler Holloway had spent 19 years inside the Special Operations community. He had worked with SEAL Team 6 operators who could put rounds through a dime at 800 meters. He had coordinated with Air Force combat controllers who could bring precision munitions onto a grid square the size of a parking space. He believed in technology, in satellites, in sensor networks that cost more than most countries' defense budgets. He believed in all of that until the morning he watched a Delta Force operator sitting in a climate-controlled room at Fort Bragg eliminate a high-value target in Kandahar province from a distance of 10,300 miles without ever setting foot on Afghan soil. Holloway was not a man who impressed easily. At 41, he held the rank of Commander in Naval Special Warfare and had served 3 tours in Afghanistan, 2 in Iraq, and 1 classified rotation that officially never happened. He had seen what American special operations could accomplish when money and equipment met training and will. He had also seen the limits. Every operation required boots on the ground. Every strike required someone in the kill chain to accept physical risk. That was the foundational principle of direct action warfare, and Holloway had built his career on understanding exactly where that principle held and where it bent. He thought he understood it completely until he received a briefing packet marked TSCI-NOFORN and containing technical specifications for a capability that should not have existed. The system was designated ARES-7, and its official categorization was Remote Precision Engagement Platform. That bureaucratic phrase concealed what the system actually did. It allowed a trained operator to fire a weapon located on one continent at a target located on another continent with accuracy measured in centimeters, not meters. The weapon itself was mounted on a robotically controlled turret housed inside a concealed forward observation post in the mountains north of Kandahar. The operator sat in North Carolina. The latency between trigger pull and firing pin strike was 47 milliseconds. Holloway read the specifications twice, then called the number listed on the cover sheet and requested a demonstration. But that was only the beginning of what he would learn. The briefing took place in a windowless conference room at Fort Bragg on a Tuesday morning in March of 2023. Holloway flew in from Virginia Beach the night before and arrived at the compound at 0600 hours. The officer who met him introduced himself only as a liaison from 1st Special Forces Operational Detachment Delta and did not provide a name. He handed Holloway a tablet computer loaded with video footage from an operation conducted 11 days earlier. The footage was thermal imagery captured from an overhead ISR platform, and it showed a compound in eastern Kandahar province that intelligence had linked to a network facilitator responsible for coordinating attacks against coalition forces across 3 provinces. The facilitator had evaded capture for 18 months. 2 previous direct action raids had resulted in dry holes. A 3rd attempt by conventional forces had been compromised 6 hours before execution when a local informant warned the target, who disappeared into the mountains for 3 weeks before resurfacing. Delta Force was tasked with eliminating him, but not through a raid, through precision engagement from a continent away. Holloway watched the footage in silence. The thermal signature of the target appeared in the courtyard of the compound at 0247 hours local time. The target stood in place for 90 seconds, appearing to speak with another individual whose signature was partially obscured by a low wall. At 0248 hours and 31 seconds, the target's thermal signature flared white for a single frame, then collapsed. The second signature moved rapidly toward the fallen figure, paused, then retreated into the structure. The timestamp in the corner of the screen indicated that the entire sequence lasted less than 4 seconds from first detection to terminal effect. Holloway looked up at the liaison officer and asked what weapon system had been used. The officer told him to wait for the full brief. The briefing itself was delivered by a Delta Force operator who introduced himself only by the call sign Anvil. He was 34 years old, had been with the unit for 7 years, and held a degree in electrical engineering from a state university Holloway did not catch the name of. Anvil explained that Ares 7 was not a single piece of technology, but an integrated system combining existing hardware in a configuration that had required 4 years of development and testing. The core components were a Barrett M82A, one rifle chambered in .50 caliber BMG, a custom fabricated robotic mount capable of adjusting aim in increments of 0.02 milliradians, a fiber optic communication link running through military satellite infrastructure, and a control interface that translated operator input into mechanical movement with latency low enough to be tactically viable. The system cost $4.3 million to develop. Each forward emplacement cost an additional $1.7 million to construct and conceal. The program had been operational for 14 months. Holloway was the first officer outside the unit to receive a technical briefing. He still did not understand why it worked. The reason it worked, Anvil explained, was not the technology. The technology was impressive, but fundamentally straightforward. What made the system viable was the operator. A conventional sniper could compensate for wind, temperature, humidity, barometric pressure, and Coriolis effect when engaging a target at 1,000 meters because the sniper could observe the environment directly and make adjustments in real time. A remote operator could not observe the environment. The operator sat in a room with no windows, no ambient temperature variation, no wind, no sun. The operator saw only what the sensors showed, and sensors could be fooled or could fail. The system required an operator who could interpret data feeds from multiple sources, construct a mental model of the battlefield environment, calculate corrections for variables that were not directly measurable, and execute a shot with a confidence level high enough to stake an operation on a single trigger pull. That level of skill could not be taught in a training course. It could only be developed through years of field work, and only by individuals who possessed a specific cognitive architecture that allowed them to function effectively in environments of extreme uncertainty. Delta Force had been selecting and training individuals with that cognitive architecture for 46 years. Holloway asked how many operators were qualified to use the system. Anvil told him that as of the current date, 11 operators in the unit had completed certification on Ares 7. The certification process took between 9 and 14 months depending on the candidate's prior experience. The washout rate was 63%. Even among Delta Force operators who had already survived a selection process with a 91% attrition rate, fewer than 4 in 10 could develop the skill set required to engage targets remotely with the precision the mission demanded. The cognitive load was described by one certified operator as similar to performing microsurgery while solving differential equations while listening to 3 radio nets simultaneously. Anvil said this without smiling. Holloway wrote it down. The next question was obvious. If the system worked, why was this the first Holloway was hearing about it? The answer, Anvil explained, was operational security. Ares 7 existed because it solved a problem that no other capability could solve. High-value targets in denied areas often operated in environments where direct action raids were tactically unfeasible or politically unacceptable. Drone strikes carried collateral damage risks that could outweigh the value of the target. Conventional sniper operations required infiltration, which introduced compromise risk and limited the engagement window to the duration of the hide. Ares 7 eliminated all 3 constraints. The system could engage targets in real time as opportunities arose, with no infiltration required, no exfiltration needed, and no American personnel at physical risk. The drawback was that the system's effectiveness depended entirely on adversaries not knowing it existed. If enemy networks learned that the United States could execute precision kills from 10,000 miles away, they would adapt their behavior in ways that would degrade or eliminate the system's utility. Therefore, every Ares 7 engagement was designed to appear as either a conventional sniper shot from a nearby hide, an unexplained equipment malfunction, or in some cases, an internal dispute within the target network. Attribution was carefully managed. The system's existence was compartmented at a level that excluded most general officers. Holloway understood the logic, but he also understood that keeping a capability this effective hidden meant accepting limits on its use. Anvil confirmed this. Ares 7 had been used operationally 17 times in 14 months. All 17 engagements had resulted in target elimination with 0 compromise events and 0 collateral casualties. The system's jackpot rate was 100%. Its compromise rate was 0%. By comparison, conventional direct action raids against similar targets during the same period had achieved a jackpot rate of 74% and a compromise rate of 19%. The difference was not marginal, it was categorical. Yet the system could only be employed in situations where its use would not reveal its existence, which meant that many viable targets were left to other methods simply to preserve the capability for future use. Holloway asked how targets were selected. Anvil said that target selection was handled at the JSOC level and that he was not authorized to discuss the criteria. Holloway did not press the issue. But the real question was still unanswered. How did an operator in North Carolina shoot a target in Afghanistan? The mechanics were explained in a second briefing, this one delivered by a warrant officer who identified himself as the primary system architect. The forward emplacement was constructed over a period of 6 weeks by a team that included Delta Force engineers, CIA technical officers, and contracted specialists whose identities were not disclosed. The emplacement was located in a ridgeline overlooking a valley that intelligence had identified as a transit corridor for multiple high-value targets. The emplacement itself was a reinforced underground bunker approximately the size of a shipping container, buried 3 meters below the surface and accessed through a concealed vertical shaft. The bunker housed the weapon mount, the sensor array, the communications equipment, and enough battery capacity to sustain operations for 96 hours without resupply. The entire structure was thermally insulated and visually camouflaged to defeat both ground observation and overhead reconnaissance. Local nationals were employed during construction under cover of a fictional infrastructure project. None of them knew what they were building. The weapon mount was the system's critical component. It was fabricated from aerospace-grade titanium and weighed 267 kilograms. The mount provided 4 degrees of freedom: azimuth, elevation, cant, and focus. Each axis was controlled by a separate servo motor capable of adjustments measured in thousandths of a degree. The motors were powered by lithium-ion batteries that were recharged via solar panels concealed in the surrounding terrain. The mount could hold position for up to 72 hours without drift, a capability that required precision machining tolerances normally associated with satellite construction rather than small arms. The cost of the mount alone was $900,000. It had no backup. If the mount failed, the emplacement was useless. The sensor array included 3 primary systems. The first was a high-resolution electro-optical camera capable of resolving details at a range of 4,000 meters in daylight. The second was a thermal imager with similar range and resolution optimized for low-light and nighttime operations. The third was a laser rangefinder that provided distance measurements accurate to within 0.2 meters at ranges up to 5,000 meters. All 3 sensors fed data into a computer that processed the information and transmitted it via encrypted fiber optic link to the control station at Fort Bragg. The latency from sensor to display was 31 milliseconds in optimal conditions. Weather, atmospheric interference, and satellite positioning could increase latency to as high as 60 milliseconds, which was still within acceptable parameters for precision engagement. The system was designed to function in conditions that would ground most manned aircraft. Holloway asked what happened if the communication link was severed. The warrant officer explained that the system had multiple redundancies. If the primary fiber optic link failed, the system automatically switched to a secondary satellite uplink. If the satellite uplink failed, the system switched to a tertiary microwave relay. If all three links failed simultaneously, the system entered autonomous mode and waited for reconnection. In autonomous mode, the weapon could not be fired remotely, but the sensors continued to collect data and store it locally for later transmission. The system had never experienced a complete communication failure during an operational engagement. It had experienced partial failures during testing, and in each case, the redundancies had functioned as designed. The control interface was located in a secure facility within the Fort Bragg complex. The facility was unremarkable from the outside, a single-story concrete structure with no signage and no windows. Inside, the facility housed 6 control stations, each consisting of a high-resolution display, a custom input device resembling a gaming controller, and a seat designed for extended use. The display showed a live feed from the forward emplacements sensor array. The input device allowed the operator to adjust the weapon's aim, trigger the firing mechanism, and switch between sensor modes. The seat was adjustable and included lumbar support. Holloway noted that the setup looked more like a sim racing rig than a military command post, and the warrant officer confirmed that the design had been influenced by gaming technology, specifically the kind used in competitive esports. The rationale was simple. The interface needed to be intuitive enough that an operator could execute complex tasks without conscious thought, and the gaming industry had spent billions of dollars solving exactly that problem. He still had not explained how a human being could hit a target from 10,000 miles away. The answer, the warrant officer said, was practice. An operator training on Ares 7 began by engaging stationary targets at known distances under controlled conditions. The operator would aim, fire, observe the impact, and adjust. This was identical to conventional marksmanship training, except that the operator received no physical feedback from the weapon. There was no recoil, no sound, no heat, no smell. The only feedback was visual. The operator watched the impact through the sensor feed and adjusted based on what the sensors showed. After the operator demonstrated consistent accuracy against stationary targets, the training progressed to moving targets, then to targets at unknown distances, then to targets under varying environmental conditions. The progression took months. By the time an operator was certified, they had fired thousands of rounds through the remote system and had developed an intuitive understanding of how the weapon behaved under different conditions. That intuition was the foundation of the capability. But intuition was not enough. The system also required calculation. Every Ares 7 engagement began with a targeting package prepared by intelligence analysts. The package included the target's known or suspected location, behavioral patterns, daily schedule, and a threat assessment indicating the level of security around the target. The package also included environmental data, weather forecasts, wind speed, and direction at multiple altitudes, temperature gradients, humidity levels, and barometric pressure. All of this data was fed into a ballistic computer that calculated a firing solution. The firing solution was not an instruction. It was a starting point. The operator reviewed the solution, adjusted it based on their assessment of the current conditions, and then executed the shot. The adjustment process was where the operator's skill mattered. A ballistic computer could account for measurable variables, but it could not account for uncertainty. Wind gusts, thermal currents, localized pressure changes, and a dozen other factors could affect a bullet's trajectory in ways that were not predictable from sensor data alone. The operator had to interpret the available information, make educated guesses about the unknowable variables, and decide whether the shot was viable. If the operator assessed that the probability of a successful hit was below an acceptable threshold, the engagement was aborted. If the operator assessed that the probability was acceptable, the operator took the shot. Holloway asked what the acceptable threshold was. The warrant officer said it depended on the target and the mission. For some targets, an 80% confidence level was acceptable. For others, the threshold was 95%. The decision was made by the operator in consultation with the mission commander. There was no formula. It was a judgment call. That judgment, Holloway realized, was what made the system work. The engagement in Kandahar province had been planned for 11 days. Intelligence had tracked the target to a compound in a valley approximately 32 kilometers southwest of Kandahar city. The compound was a traditional Afghan structure, 2 stories, mud brick walls, flat roof, surrounded by a perimeter wall approximately 2 meters high. The compound housed the target, his family, and an unknown number of security personnel. Previous surveillance had established that the target followed a relatively consistent pattern. He woke before dawn, performed morning prayers in the courtyard, then spent the early morning hours in a ground-floor room that analysts believed was used as an office. He left the compound infrequently, usually traveling in a convoy of 2 or 3 vehicles with armed escorts. Direct action raids had been considered and rejected. The compound was located in an area with limited helicopter landing zones, and the approach routes were exposed to observation from nearby villages. An air assault would almost certainly be detected before the assault force reached the objective, giving the target time to flee or barricade himself inside the compound. A ground infiltration would require moving through populated areas, which introduced unacceptable compromise risk. A drone strike was ruled out due to the presence of civilians in the compound, including children. Ares 7 was the only option that met the operational and political constraints. The forward emplacement used for the engagement had been in place for 7 months. It was located on a ridgeline approximately 4,100 meters from the target compound, positioned to provide a clear line of sight to the courtyard. The emplacement had been used for 3 previous engagements against different targets in the same valley, all of which had been successful. The operator assigned to the engagement was a Delta Force sergeant with 9 years in the unit and 14 months of Ares 7 certification. His call sign was Sandman, and he had executed 6 previous remote engagements with a 100% success rate. Sandman began preparing for the engagement 4 days before the scheduled execution window. He reviewed the targeting package, studied overhead imagery of the compound, analyzed weather forecasts, and ran simulations using historical data from previous engagements in the same area. He also reviewed video footage of the target to familiarize himself with the target's physical appearance, gait, and behavioral patterns. By the time the engagement window opened, Sandman had spent more than 30 hours preparing. The engagement window was defined as the period during which the target was most likely to be observable in the courtyard. Based on previous surveillance, this period was between 0230 and 0330 hours local time. Sandman took his position at the control station at 0100 hours, 2.5 hours before the window opened. He powered up the system, ran diagnostics, and confirmed that all sensors were functioning correctly. He then began monitoring the live feed from the emplacement. The courtyard was empty. The compound was dark except for a single light visible through a ground floor window. Sandman waited. At 0218 hours, a door on the ground floor opened, and a figure emerged into the courtyard. Sandman zoomed the electro-optical camera and confirmed that the figure matched the target's physical description. The target walked to the center of the courtyard, paused, and appeared to light a cigarette. Sandman measured the range to the target, 4,093 meters. He checked the environmental data. Wind speed at ground level was 3 meters per second from the northwest. Wind speed at altitude was estimated at 6 meters per second, also from the northwest. Temperature was 8 degrees Celsius. Humidity was 42%. Barometric pressure was 1,013 millibars. Sandman entered the data into the ballistic computer and received a firing solution. He reviewed the solution, made minor adjustments based on his assessment of localized wind conditions, and moved the crosshairs onto the target's center mass. But he did not fire, not yet. The target remained in the courtyard for 47 seconds. During that time, a second figure emerged from the compound and approached the target. The two figures stood approximately 1 meter apart, partially obscured by the perimeter wall. Sandman could not take the shot without risk of hitting the second individual, who had not been identified as a target. He waited. At 02:47 hours, the second figure turned and walked back toward the compound. The target remained in place, alone, visible from the chest up above the perimeter wall. Sandman recalculated the range, 4,091 meters. He adjusted his aim by 0.03 milliradians to account for the slight movement. He checked the wind data again. No significant change. He placed the crosshairs on the target's upper chest, just below the collarbone. He exhaled slowly, held his breath, and pressed the trigger. The delay between trigger press and impact was 1.4 seconds. The bullet traveled 4,091 meters, dropped approximately 11.2 meters due to gravity, and drifted 0.7 meters to the right due to wind. It struck the target in the upper chest, approximately 3 centimeters below the intended point of impact. The target collapsed. The second figure, who had reached the doorway of the compound, turned and ran back toward the fallen target, paused for approximately 2 seconds, then retreated into the compound. Sandman observed for an additional 60 seconds to confirm that the target did not move, then reported mission success to the operations center. The entire engagement, from target identification to confirmation of effect, had taken 2 minutes and 31 seconds. Holloway watched the footage 3 times. He could not identify anything in the sequence that would have indicated to an observer that the shot had come from a remote location. There was no visible muzzle flash, no sound signature that would have been audible at the compound, no indication of where the shot had originated. To anyone at the scene, the engagement would have appeared to be the work of a conventional sniper positioned somewhere in the surrounding hills. That ambiguity, Anvil explained, was by design. Every Ares 7 emplacement was positioned to mimic the firing position a conventional sniper would choose. The weapons report was suppressed to minimize acoustic signature, and the emplacement's concealment ensured that muzzle flash was not visible from the target area. Enemy forces investigating the incident would find no physical evidence at the emplacement site because no personnel had been present. They would conclude that a sniper had been in the area, taken the shot, and exfiltrated before they could respond. The conclusion would be correct in every detail except the distance from which the shot had been fired. Holloway asked how long the emplacement could remain operational before it was discovered. Anvil said that the longest any emplacement had remained in place was 13 months, and that emplacement had been deactivated not because it was compromised, but because the target set in that area had been exhausted. The system's concealment was robust enough that even prolonged enemy search efforts had failed to locate the emplacements. In one case, insurgents had conducted a 3-day sweep of an area where they suspected a sniper had been operating. They passed within 15 meters of the emplacement and did not detect it. The search was called off when they found no evidence of human presence. The statistics left no room for interpretation. 17 engagements, 17 successes, 0 compromises, 0 collateral casualties, average time from target identification to elimination, less than 4 hours. Average cost per engagement, approximately $190,000, including system maintenance, communication costs, and personnel. By comparison, a conventional direct action raid against a similar target required an average of 12 to 16 operators, multiple aircraft, and support personnel numbering in the dozens. The cost per raid ranged from $800,000 to $2.1 million, depending on the distance to the target and the level of opposition. The compromise rate for conventional raids was 19%. The collateral casualty rate was 11%. RE-7 delivered better outcomes at a fraction of the cost, with none of the risk. Yet Holloway remained skeptical, and he told Anvil why. The system, he argued, worked because it had been employed against targets who did not know it existed. The moment adversaries understood that the United States could execute precision strikes from thousands of miles away, they would change their behavior in ways that would make the system ineffective. They would avoid open areas. They would move unpredictably. They would employ decoys. They would operate in locations where line-of-sight engagement was impossible. The system's perfect record was a function of surprise, not inherent superiority. Once the surprise was lost, the capability would degrade to irrelevance. Anvil listened without interrupting, then asked Holloway a question. If an adversary knew that any time they stepped into an open area, they could be killed from a location they could not identify, by a weapon they could not see, with no warning and no opportunity to respond, how would that change their behavior? Holloway thought about it for a moment and admitted that such knowledge would impose severe operational constraints on the adversary. Anvil nodded. That, he said, was the point. The conversation shifted to the second question Holloway had been asked to evaluate: scalability. Could Ares-7 be expanded beyond its current footprint? Could additional emplacements be constructed in other theaters? Could more operators be trained? The answer to all three questions, Anvil explained, was yes, but with significant caveats. Each emplacement required months to construct and cost more than $1.7 million. Each emplacement required site surveys, engineering assessments, and operational planning that tied up specialized personnel for extended periods. The construction process required moving heavy equipment into remote areas without attracting attention, which was not always feasible. Some potential locations were ruled out because they were too remote to access covertly. Others were ruled out because they offered insufficient fields of observation. Still others were ruled out because the political environment made covert construction impossible. Of the 42 potential sites that had been evaluated over the past 3 years, only 7 had been approved for development, and only 4 had been completed. The bottleneck was not money. It was time, expertise, and opportunity. Operator training was a similar constraint. Delta Force had a finite pool of personnel, and only a subset of that pool possessed the cognitive traits required for remote engagement. The certification process took more than a year, during which the candidate was not available for other operational assignments. Training one operator on Ares-7 meant that operator could not be deployed on direct action missions, could not participate in partner force training, and could not fill billets in other high-priority programs. The unit had to make trade-offs. Every operator assigned to Ares-7 was an operator who could not do something else. The unit currently had 11 certified operators, with 3 more in the pipeline. Expanding that number to 20 would take at least 2 years and would require pulling operators from other critical roles. Expanding beyond 20 would require either growing the unit's overall manning, which was not feasible given current recruitment and retention rates, or accepting degraded capability in other mission areas. Holloway understood the math. Ares-7 was a niche capability optimized for a specific problem set. It was extraordinarily effective within that niche, but it could not replace conventional direct action operations, and it could not scale to become the primary tool for high-value targeting. The system's value was strategic, not operational. It provided decision-makers with an option that did not exist before: the ability to eliminate specific individuals in specific situations without putting American personnel at risk and without generating the political blowback associated with drone strikes. That was valuable, but it was not a silver bullet. But there was a third question Holloway had not been asked to evaluate, and he asked it anyway. The system worked by removing human beings from the battlefield. The operator sat thousands of miles away, insulated from physical danger, observing the target through a camera, executing the engagement with a button press. There was no risk, no fear, no adrenaline, no immediate consequence if the shot missed. There was only data and decision. Holloway wanted to know if that distance changed the operator's psychology in ways that might affect judgment or decision-making. Anvil's answer was immediate and unequivocal: no. The operators who used RE-7 were the same operators who had spent years conducting direct action missions in hostile territory. They had breached doors, cleared rooms, engaged targets at close range, and carried wounded teammates out of kill zones. They understood the stakes. The fact that they were physically distant from the engagement did not diminish their sense of responsibility. If anything, it increased it. An operator executing a raid had seconds to make life or death decisions under extreme stress. An operator using RE-7 had hours or days to prepare, access to extensive intelligence, and the ability to abort if conditions were not perfect. The decision to fire was more deliberate, not less. The operator knew that once the trigger was pressed, a human being would die, and that knowledge carried weight regardless of the distance involved. Holloway accepted the answer, but remained unconvinced. He suspected that over time, as more operators cycled through RE-7 training, and as the system became normalized within the unit's operational toolkit, the psychological distance might begin to have subtle effects. He did not press the point. He filed it in his mental notes as a question worth revisiting in a few years. The briefing concluded with a question from Anvil. Holloway had spent the morning learning about a capability that fewer than 50 people in the Department of Defense knew existed. He had seen footage of an engagement that would never be publicly acknowledged. He had been given access to technical details that were compartmented at the highest levels. Anvil wanted to know what Holloway thought, not as an evaluator, not as an officer writing a report for senior leadership, but as someone who had spent 2 decades in the special operations community and who understood what was possible and what was not. Holloway took a moment before answering. He said that RE-7 represented a paradigm shift in how precision targeting could be conducted, and that the system's operational record spoke for itself. He also said that the system's long-term viability depended on factors that were outside the unit's control, including adversary adaptation, political support, and continued funding. He said that the capability was valuable and should be preserved, but that it should not be oversold. It was a tool, not a solution. Anvil thanked him for the assessment and escorted him out of the facility. Holloway flew back to Virginia Beach that evening and spent the next 3 days writing his evaluation. The evaluation was classified top secret and addressed to the commander of Joint Special Operations Command. It included a detailed technical assessment, a cost-benefit analysis, and a set of recommendations for future development. The core recommendation was simple: continue funding RE-7, expand the number of emplacements to 10 within the next 3 years, and increase the operator training pipeline to support a total of 20 certified personnel. The report also recommended that the system remain compartmented and that operational employment be limited to situations where its use would not reveal its existence. The report concluded with an observation that Holloway had debated, including but ultimately decided, was important. He wrote that RE-7 worked not because of the technology, but because of the operators. The system's effectiveness was a direct result of the selection and training process that produced individuals capable of functioning in environments of extreme uncertainty with minimal supervision and maximum autonomy. That process could not be replicated by simply purchasing better equipment or hiring more personnel. It required an institutional culture that valued initiative over compliance, that accepted high failure rates during selection, and that invested years in developing skills that had no immediate return. Most organizations, military or otherwise, could not sustain such a culture. Delta Force had sustained it for nearly 5 decades, and that was why Ares 7 existed and why it worked. 2 weeks after submitting his report, Holloway received a call from an officer at JSOC thanking him for the assessment and informing him that his recommendations had been briefed to the appropriate authorities. The officer did not say whether the recommendations had been accepted or rejected, and Holloway did not ask. 3 months later, he learned through informal channels that funding for 2 additional Ares 7 emplacements had been approved. He took that as confirmation that someone had read his report and agreed with at least part of it. He thought about the system occasionally over the following months, usually when reading intelligence reports about high-value targets being eliminated in locations where direct action raids would have been difficult or impossible. He could not know for certain whether any of those eliminations had been conducted using Ares 7, but he suspected that some of them had been. The system's existence had not been revealed, which meant it was still operational, which meant it was still working. That was the only metric that mattered. 6 months after the briefing, Holloway was promoted to captain and reassigned to a staff position at Naval Special Warfare Command. His new role involved oversight of acquisition programs and technology integration, which gave him visibility into a wide range of classified capabilities across multiple services. He saw systems that cost billions of dollars and delivered marginal improvements over existing platforms. He saw programs that had been in development for a decade and had yet to produce a working prototype. He saw technologies that looked impressive in presentations but failed under operational conditions. Ares 7 was none of those things. It was a relatively simple system built from existing components, developed in less than 4 years, and operational in less than 5. It worked because the people who designed it understood the problem they were trying to solve, and did not try to solve adjacent problems at the same time. It worked because the operators who used it were selected for their ability to function in exactly the kind of environment the system required. It worked because the organization that fielded it had the discipline to keep it secret and the patience to employ it only when conditions were right. Holloway wrote a second report 18 months after his first visit to Fort Bragg, this one addressing broader questions about how Special Operations Forces integrated advanced technology. The report used Ares 7 as a case study, but did not identify the system by name. The core argument was that technology succeeded when it amplified human capability rather than attempting to replace it, and that the most effective systems were those designed around the people who would use them rather than the other way around. The report was circulated at the 06 level and generated some discussion, but no policy changes. Holloway had not expected policy changes. He had written the report to document lessons that might be useful to someone in the future who was trying to make similar decisions about similar systems. 3 years after his initial briefing on Ares 7, Holloway attended a change of command ceremony at Fort Bragg for a senior officer who had served as a liaison between JSOC and the intelligence community. During the reception following the ceremony, Holloway found himself standing next to a Delta Force operator whose face he recognized but whose name he did not know. They exchanged pleasantries, and the operator asked if Holloway was still working on acquisition programs. Holloway said he was. The operator mentioned that he had heard good things about a report Holloway had written a few years earlier regarding technology integration in special operations. Holloway thanked him and said the report had been based on observations from a visit to a particular program at Bragg. The operator smiled and said he knew which program Holloway was referring to. He also said that the program was still running and still delivering results. Holloway asked how many emplacements were now operational. The operator said he could not answer that question, but that the number was higher than it had been 3 years ago. He also said that the system had recently been employed in a new theater and that the results had exceeded expectations. Holloway did not ask which theater. He knew he would not get an answer, and he did not need one. The conversation shifted to other topics, but Holloway found himself thinking about the program later that evening. He realized that RE-7 represented something rare in the defense acquisition world, a capability that had been conceived, developed, tested, fielded, and employed successfully within a time frame that most programs could not match, and at a cost that most programs could not approach. The system had not been built by a major defense contractor. It had been built by a small team of engineers, operators, and technicians who understood the problem they were solving and who had the freedom to iterate quickly without bureaucratic interference. The system had not been marketed. It had not been briefed to Congress. It had not been featured in trade publications or discussed at defense industry conferences. It simply worked, and it continued to work because the people responsible for it understood that the system's value depended on its obscurity. Holloway spent the remainder of his career in positions that gave him insight into dozens of classified programs across multiple domains. He saw systems that redefined what was possible in electronic warfare, undersea operations, cyber operations, and space-based intelligence. He saw capabilities that would have seemed like science fiction a decade earlier. But he never saw another program quite like RE-7. Most systems were designed to be scalable, to be employed widely, to be integrated across multiple platforms and services. RE-7 was designed to be narrow, to be employed sparingly, to remain invisible. It succeeded because it accepted those constraints rather than fighting against them. The system did one thing extraordinarily well and did not try to do anything else. That focus was what made it viable, and that focus was a direct reflection of the organization that created it. Years later, when Holloway retired from active duty and began working as a consultant on defense technology issues, he was occasionally asked by clients or colleagues whether the military was investing enough in remote engagement technologies. His answer was always the same. The military was investing in remote engagement, and some of those investments were producing useful capabilities. But the most effective systems were not the ones with the highest budgets or the most advanced technology. The most effective systems were the ones built around people who could make decisions in situations where algorithms failed and where doctrine provided no clear guidance. Those people could not be hired on the open market or trained in a 6-month course. They had to be developed over years through a selection process that most organizations would consider wasteful because it rejected so many candidates. Delta Force had been running that process since the late 1970s, and it had produced a pool of personnel capable of employing capabilities like RE-7 in ways that no other organization could match. The technology mattered, but the people mattered more. Holloway never disclosed the existence of RE-7 to anyone who did not already know about it. The briefing he had received at Fort Bragg remained the most detailed technical overview he had ever been given of a classified capability, and he treated that information accordingly. He occasionally wondered whether the system was still operational or whether it had been retired as adversaries adapted or as new technologies made it obsolete. He had no way of knowing, and he did not try to find out. Some questions were better left unanswered. What he did know was that the system had changed his understanding of what precision engagement could look like. Before RE-7, he had assumed that striking a target required someone to be physically proximate to that target, either on the ground or in the air. The system had proven that assumption wrong. It was possible to engage targets from thousands of miles away with accuracy that matched or exceeded what conventional snipers could achieve at close range, provided the right people operated the system and provided the system was employed under the right conditions. That insight had implications far beyond RE-7. It suggested that many of the constraints that military planners took for granted were not physical constraints, but conceptual constraints, and that those constraints could be broken by people willing to think differently about how operations were conducted. The final lesson Holloway took from Ares 7 was about secrecy. The system worked because almost no one knew it existed. The operators who used it did not discuss it. The commanders who authorized its use did not acknowledge it. The intelligence officers who supported it did not write about it. The system's success depended on a level of operational security that was almost impossible to maintain in an era of leaks, media scrutiny, and congressional oversight. Yet the security had held for years, and as far as Holloway knew, it was still holding. That discipline, he believed, was as important as the technology itself. A capability that could not be kept secret was a capability that could not be sustained, and a capability that could not be sustained was not worth developing in the first place. Holloway never wrote about Ares 7 in any unclassified context. He never mentioned it in interviews or public speeches. He never hinted at its existence in articles or opinion pieces. He had been entrusted with information about a system that saved lives and delivered strategic effects, and he honored that trust by saying nothing. When he thought about the system, which was rarely, he thought about the operator sitting in a climate-controlled room in North Carolina, watching a screen, calculating wind drift and drop, and pressing a trigger that sent a bullet across 10,000 miles to eliminate a target who would never know where the shot came from. He thought about the discipline required to develop that skill, the judgment required to employ it responsibly, and the culture required to sustain it over years and decades. He thought about all of that, and he understood why Delta Force remained what it had always been, an organization that did not advertise its capabilities, did not explain its methods, and did not need to. The unit had been built on the assumption that some problems could only be solved by people who were willing to operate in environments where failure was always possible and where success could never be publicized. Ares 7 was a perfect expression of that assumption. The system existed because someone had asked whether it was possible to engage targets from a continent away, and someone else had answered yes, but only if we can find the right people to do it. They had found those people, and the system worked. That was the only story that mattered, and it was a story that would never be told.